safety at the Swedish National Road and Transport Research Institute, VTI, and an adjunct professor of injury prevention at Chalmers University in Sweden. Astrid, the floor is yours.
Thank you very much, and thank you for this opportunity to talk about this great initiative that we have been given the opportunity to have. It's the virtual project, and I'm the coordinator. And virtual project, the whole title is Open Access Virtual Testing Protocol for Enhanced Road User Safety. And the topic was addressing all road users. So we have a clear focus on all road users, and also not only fatalities but injuries and severe injuries in terms of also addressing disabling injuries. And when it comes to occupants, this is the most common and costly injury is, as some of you might be aware of, the whiplash injury, the soft tissue neck injury that occurs in low velocities. So you will hear more about this one later, because this is one of our test cases where we actually take the whole chain from the virtual models to the physical models and show all the steps in the chain. So we started in 2018, and we will end this year. If we get the extension that we are applying for, we will end a bit later this year, but it will be within this year. We have a budget of 7 million euros, and of course a website that you can look into if you find this interesting. We are 15 partners around Europe, and we have a rather equal split between academies, institutes, SMEs, and companies. So you see here from the chart that we have the bigger university, but also big companies such as Siemens, Volvo, and Faurecia. So and Dorel, I should also mention. So we applied. We looked at what we wanted to achieve, and then we picked the partners that could make this happen. Our overall goal is to, of course, then reduce loss of life and health in road crashes. So this is about the crashes that occur. We in this tool chain that we have developed, we also look at how to avoid crashes and the effect of that. But we know that for the foreseeable future we will have crashes that occur, and the question is how best to develop the safety systems, and that will be then the passive safety systems, so that we don't lose our life and health. We aim at identify protection innovation by using virtual testing and human body models. You heard already a lot about human body models from Werner, and thank you, Werner, for having introduced many of the topics that comes here, so you will hear it again and it will feel more familiar to you. And we do this by taking a totally new approach when it comes to the norm and the models of the human that we use. As you have seen earlier today also, our norm is the average male, and we have a small female and a large male to cover the range in terms of height and weight. However, we have until now been missing the average female. So our approach is to have an average female and an average male human body model as the starting point, so that they always come in a pair. They are designed using the same setup of data, the same modeling approach, and from there we can vary height, weight, age, and so on. So this is the starting point for this project. In addition, we also have a strong aim to share and foster knowledge. So we decided to do this all open source. So this has been a fantastic force in the project, keeping up a fantastic spirit, and have avoided us from going down the track of who is owning this and how could we share it, because we know that what we do, we will share with the whole world. And I'll show you how. Of course, these 15 partners is not enough. So we have a big international collaboration with universities, organizations around the globe. And here I can highlight in particular OMTRI, where we get the base data for our human body models of the average female and the average male, because such data exist. It's only that we have so far used the male data, and we do both. Also, Insurance Institute for Highway Safety, I want to highlight, because they play a very important role in the US, very quite similar, or with some similarities to your NCAP here, with being very active in when it comes to testing and addressing what they see as needs from the insurance perspective. And then coming to Europe, want to highlight, of course, Euro NCAP, that is an associate partner that we work with in close collaboration throughout the whole project, and French car manufacturers and Toyota. And then going to Japan, we have YARI, and all the way down then around the globe to Australia, where we collaborate with and got data from the world's largest tram network, because we also look at occupants in public transport. So we are organized quite traditionally. We have the work package 1, where we do all the infrastructure, where we are sharing our everything that we do. And this is also where this open VT is established, where OSCAR have placed some of its material. We have work package 2, where we develop our human body models, and that is models with skeleton and all soft parts and so on, as we humans consist of, in contrast to dummy models, which represent parts of plastic and metal and so on. And then we have our 3 use cases: the occupant in the vehicle, the vulnerable road users, cyclists and pedestrians, and then work package 5, passengers in public transport. Then in addition, we have a whole work package for cost-benefit analysis. So we provide from our simulations input to a cost-benefit analysis tool that has been created to assess the results in terms of cost and benefits. So, of course, we started off with doing an extensive literature review of the different road users in the vehicles, vulnerable road users, cyclists and pedestrians, and also standing occupant in public transport, which is our focus here. And from there, we identified the most common injuries and the type, the frequencies, and ensuring that we are addressing something that we know is a challenge today, and that is highly likely to be a challenge also tomorrow. As I already mentioned, our way to make this available is that we established an Open VT platform, and it's on the GitLab server. Everybody can access there, and you find what I show today, and much more, of course, here. What should I? Yeah, I think that's it. I will deep down into the human body models directly. Of course, we have, as Werner also explained, we are looking at injury, functions, criteria, all tools, and so on. So I would just give you a few highlights from the project, so that you don't think I cover everything here. The human body models, we call them Viva Plus models of an average male and an average female. You see them here side by side, and you also see the different in proportion in terms on the red and the blue occupants. So there you see the difference that this average make. Broader than that, the tools, of course, the occupants model are then made into standing occupants. The standing occupant is also made so that it can sit on a bicycle. So we have developed a bicycle so that we can look at different bicycle postures and see what is the most severe in terms of postures. Let's see, do you have a cursor? Yeah, I have it here. You see it? Yeah, excellent. Okay, we also have a simplified structure of a vehicle for the pedestrian. For the pedestrian also we have a shoe that you need. We also develop open source seat models. This is seat models where we have had done volunteer tests, low severity testing. So this is some seat model, open source, that can be used to assess different human body models that you want to use in a test, in a virtual testing. Also, we have a seat model of an Toyota Yaris, where there is a lot of data on performing, how it's performed, in particular in rear impact and how it protects the occupant. And we also address children, so there are a number of child seats that you can use. Going then to the occupant, standing occupant in public transport. Here you see an interior for a tram, I think it was, or a bus. And also we have a contour of a tram. And then I told you about the whole chain. And here we go for the seated occupant, low severity crashes. We have made both. We have made actually physical seat evaluation tools that are models of the human that for assessing the safety of the injury protection performances of the seats. So here I will show you the Viva Plus model, the average female, in a rear impact in the Toyota seat. So this is an example of the tools that are available that everybody can access and improve and be part of this big community. Here you also see actually the first picture of the seat evaluation tool, the physical one, that is now being put together and is doing its first test. We will have an equivalent set. Here you see that it's the average female, also of the average male, and starting to build our knowledge on this platform. So, looking at the volunteer test, or the standing occupant in public transport, there we looked in particular to how you maintain balance when you are on a moving platform. And looking at normal driving, not emergency events, but under normal driving, like takeoff and braking, because there we saw from the injury statistics, and this one was from Melbourne, from this big trams system, that there were actually injuries caused during normal takeoff and braking. So we did a series of volunteer tests to identify what motion patterns that are the most efficient in terms of maintaining balance, as an example. And then we took the data further on into the simulations. First, working with OpenSim to look at the motion broadly, and then into these, actually these are active muscles, models that also Werner told you about, that respond to the motion. Here, just to show you that the cost-benefit analysis tool is available, and that you can use this and impact or put your input into it, and of course improve and so on. Cross-project collaboration. We have had the fortune of being 3 projects that were funded in the same under the same scheme. And we have benefited a lot from that. We have had 3 events. First, we had a virtual OSCAR Pioneer event. And then we had 2 virtual and OSCAR workshops where we actually were able to gather globally the stakeholders here, and have Euro NCAP, Toyota with the thumbs model, and Insurance Institute for Highway Safety as an example, to show and describe where they are. And actually, during this project, the thumbs models were made publicly available. Before, they were only available if you paid a fee. So yeah, that was some example. Cross-project collaboration and impact. Here you see that OSCAR group down there in the list, they have some material here, and also already Euro NCAP have put some material on our OpenVT. Of course, a lot of scientific publications. These are all the peer-reviewed gold open access publications, and in addition to this, a large number of presentations and yeah, other events. Finally, then, to impact. You might be aware of that we have now an ad hoc group within the UNECE, which aim at looking at diversity of occupants and how the testing can reflect the population more broadly than it does today. Because in the regulatory test, as you might be aware, the requirement is that you use the average male. We also have Euro NCAP aiming at, is to my knowledge, that they have set the date now for 2029 to go into virtual testing as a complement to physical test. And then a question that we already knew from the start would come. What do we do when the project is over? How do we make this alive still after the project? So we have established an organization, the OpenVT organization. It is situated in Switzerland, Zurich, and it's the starting point for taking this further than we will be able to do within the project. So with that, if you have further questions after this day, please don't hesitate to contact me. Thank you for your attention.